Hello everyone, myself Deepika, working as an assistant professor in RPIIT Technical and Medical Campus, Bastada, Kannauj. Today we are going to discuss about detectors used in the spectroscopy. First, we define detectors. Detectors are the transducers that convert radiant energy into the electrical signal. Ideal properties of detectors: high sensitivity, a constant response over range of wavelengths, fast response time, zero output signal in absence of illumination. Signal should be directly proportional to the power of incident radiation. There are two types of detectors: quantum detectors and thermal detectors. Quantum detectors that are respond to photons. They are photoconductors and only photoconductors are used in IR. Other phototransducers are not used in IR as lack of energy to cause photo emission. Quantum detectors respond to individual photons. Sensitivity is depend on wavelength but is higher than the thermal detectors. Thermal detectors that are respond to heat. These are thermocouple, thermopiles, bolometer, resistance thermometer, thermistors, Gole cell, gas thermometer, and pyroelectric. These are useful for IR radiation. Thermal detectors respond to average power of incident radiation. Sensitivity is independent on wavelength but lower than sensitivity of photoelectric detectors, slow speed and low dynamic range. Most of the quantum detectors are used for measurement of UV visible and NIR radiation as they have sufficient energy. When they are used for long wavelengths, they must be cooled to dry ice or liquid nitrogen temperature to avoid interference from thermal background noise. Thermal transducers that response depend upon the heating effect of radiation. Because these are only response for heat, radiation is absorbed by a black body and resultant increase the temperature is measured. First, thermocouples, a pair of junction formed when two dissimilar semiconductor, antimony and bismuth, fused to either end. Potential difference develop between the junction as change in temperature. Second, bolometers and resistance thermometer. These are constructed of strips of metal such as platinum or nickel and produce large change in resistance as a function of temperature. Thermistors, similar to bolometer but a semiconductor is used, produce decrease in resistance. Fourth, Gole cell and gas thermometer. Heating of gas reflected by proportionate increase in current. Pyroelectric, temperature dependent polarization reflected by proportionate increase in current. Thermal noise from surrounding should be minimized by housing the detector in vacuum, and beams are chopped to minimize the effect of extraneous heat source. This is a diagram for a thermocouple detector. There is a two junction, reference junction and detector junction. At a detector junction, IR radiations are enters and there are two atoms, antimony and bismuth, are connected at the both end, reference junction and detector junction. Next diagram for a bolometer. रिस्पॉन्सिव एलिमेंट से जो IR रेडिएशन है वो एंटर करती हैं. दीज आर मेड अप ऑफ स्ट्रिप्स ऑफ मेटल्स लाइक प्लेटिनम और निकल और सेमीकंडक्टर. The metals have the high temperature coefficient, that is their temperature increase with increase in temperature, and exhibit large change in resistance with temperature. The resistance of the metal is directly proportional to the temperature. Thermistor, the negative temperature coefficient means their resistance decrease with increase in temperature. Thank you. Have a nice day.